Hey guys, and welcome to your next advanced C++ and graphics tutorial. Today we are going to finally add some primitive audio into our game. And now when I say primitive, I do mean primitive. It's not going to be very complicated. If you want to add complicated audio into your game, I would recommend you look up something called FMOD Studio. FMOD has a development library that you can use for audio that's way more advanced than what I'm going to teach you, and I believe they do have like an indie license where you don't have to pay for it unless you start selling it or something like that. Just do a little research on that. But what we're going to be using is SDL Mixer. Now what SDL Mixer is it's a small library that's built on top of the normal just default SDL audio stuff, because SDL2 does have some audio, but it's very low level. And what SDL Mixer does is it gives you a higher level way to actually do audio stuff. And what we're going to do is download SDL Mixer, and then we're going to write our own audio engine on top of SDL Mixer so that we can add our own custom functionality and just give ourselves a really basic audio engine that doesn't really do a whole lot except play sounds and music. So what you'll want to do is download the development library. If you're on Mac OS, of course, click that. If you're on Visual Studio Windows, click that. Otherwise, you're going to use the Mingy W1. Go ahead and download that, and then put it in your little deps folder. So I extracted it to the deps folder, and now what you need to do is of course put everything in the correct place. So in the include folder that you downloaded, there's going to be an sdlmixer.h. What I did is I just put it in the include SDL folder along with all the other SDL files. Now there's also in the lib folder x86 there is a sdl2mixer.lib. Make sure to grab that and drop it in the lib folder with all the other SDL libraries. And then finally, there is in the lib folder x86 all of these DLLs. Just go ahead and click on all of those and copy all of them, and then take them out into your main folder. You should have a debug folder with all of your other DLLs in it alongside your exe. Go ahead and paste them here. Do the same for the release, paste them here. So that's it for the installation. Actually, there's one more thing you need to do. You need to go into Zombie Game, or whatever game you're using to do audio, and you'll go into the linker, into the input here, edit, and you're going to want to add sdl2mixer.lib after sdl2ttf.lib to make sure that it knows that you want to link that library. And make sure you do it for both release and debug mode. I always forget to do it for both. It won't compile on one if you switch. So sdl2mixer.lib and apply. Alright, so now that we have SDL Mixer, we can start creating our little class for our game engine. So let's go ahead and go into Bingin, and we're going to click Add Class, and let's just give it a very generic name like Audio Engine, like that. So we'll go ahead and click that. So now we have our Audio Engine class. Let's go ahead and include it in the Bingin namespace. Of course, if your game engine is named something else, you will use a different word here. Namespace Bingin. Like that. And we also need some includes at the top. We're going to need to include SDL Mixer. So if you're not getting this include here, then that means something went wrong with your installation. You probably forgot to put the sdlmixer.h file in your SDL folder, in that deps folder. So there we have the SDL Mixer now. Now we can start setting things up. So what functions are we going to need? Well, we're going to need in our audio engine an init function, of course, to initialize the audio. And let's also have a destroy function. Anytime you're making any kind of interface like this, you're probably going to have an init function and a destroy function. Now, destroy function is what gets called whenever you want to clean everything up, once you want to release all the resources, delete all of your audio and all that stuff. And now we're going to want to be able to play audio files. We're going to want to play, there's two different kinds of audio files that SDL Mixer does. It has what's called a mix chunk, which is basically a sound effect, and it has a mix music, which is a music file. Now we're going to write our own little wrappers around those. So we're going to create our own class in here. We'll say class sound effect, and this will be, of course, a sound effect. We'll say public, and it needs to be able to play a sound. So let's just for now say void play, and we'll fill that out later. And it's going to have some private variables as well. So what the sound effect is going to be wrapping is the mix chunk. So if we type mix chunk like that, star, and I'm going to use the naming convention m underscore for a private member variable, m underscore chunk, and we want to initialize that to null pointer. Remember in the previous tutorial we learned about header initialization. Alright, so this sound effect, right now it's just a really basic class that's just wrapping this mix chunk. Now I'm going to teach you the basics of SDL Mixer, but I'm not going to teach you everything about SDL Mixer. If you want, you should go to that download page at this documentation here. Click on one page here, and it's got all the documentation, everything you would need. If you go to the very bottom, there's a big list of all the classes and stuff and what they all do. And there's a bunch of examples up here on how to use it. Since I'm not going to teach you everything in detail, you can come in here. Like there's stuff for fading music in and out and things like that that you might find useful. All right, so there's our sound effect class for now. Now we also are going to want a class music. So this is for playing just normal music. Public, we're going to do void play, of course, and we'll probably change the parameters around. And private, this, instead of a mix chunk, we use a mix music. We're going to say m music equals null pointer. Always want to initialize that to null. Okay, and now what we want to do is actually create a way for us to be able to get these sound effects and these music files. And we're going to want to store them in our audio engine. The audio engine is sort of going to be the manager for all of these music and sound effects. So what we're going to want to do is have a function to load a sound effect and a function to load music. So for loading sound effect, let's go ahead and call it, we'll say sound effect. So it's going to return a sound effect. Now I'm not going to return a sound effect pointer. I'm not going to allocate anything with new. I'm just going to return a copy of a sound effect. Since it's just a wrapper around a mix chunk right now, it's only going to be returning a copy of 8 bytes. So we're not going to run into any, massive overhead or anything crazy like that. And now we could call this, we could call this load sound effect. And what it's going to do is it's actually not always going to load the sound effect. What we're going to do is pretty much the same thing we did with our texture cache. It's actually going to cache the sound files. So if you ask to load the same exact sound file twice in a row, it's actually going to only load it once. And the second time, it's just going to return you a pointer to that same chunk, that same mix chunk. All right, so we need to say what the file path is. So we're going to go ahead and say const std string reference parameter. So remember, the reason I'm making this a reference is because I don't want to copy the whole string. If it's a big long string, that's a pretty expensive operation. And I'm saying const because it's never going to change. You should always say const with reference parameters if you know they're not going to change. And so that's going to be file path. Okay, and let's do the same thing for loading music. So we're going to say music, load music, const std string, and we'll say file path. And this is going to return to us an instance of these two classes here. And we're getting an error because we need to include string up at the top. Okay, now let's go into audioengine.cpp. Now everything is going to be wrapped in namespace bingin. All right, because this is all part of the bingin, or whatever your game engine is. And now we need to actually implement some of these functions. So what we're going to do is let's go ahead and start with, let's skip sound effect and music playing right now. Let's just start with the actual audio engine. So we're going to need to copy all 4 of these. We'll put them down here. We need to preface them with audio engine. Now if you have Visual Assist, there's an easier way to do this rather than copy pasting all this stuff, but I'm not going to show you that for now since I'm assuming most of you do not have Visual Assist since it's not free. It does have a free trial, but that runs out. And okay, so here's all of our little function bodies. Now first, let's go ahead and tackle the init function. So the init function is going to be really simple. It's just going to call 2 functions. And what we want to do is, first thing we want to do is call mix init. So this is the base init function. And we only want to call audio engine init after we have initialized SDL. So if we go into main game here, let's see, we have in init systems, we have SDL init, I believe. Or maybe the window initializes SDL. Somewhere. I don't even remember where we call SDL init, but it's in here somewhere. Oh, bingin init. Here we go. So whenever we call bingin init here, this will initialize everything for SDL, including the audio. So we just want to make sure that whenever we create our audio engine and initialize it, it happens after the call to bingin init. It's something to consider. All right, so anyways, this mix init function. So what it does is it just sets up the basic initialization stuff, and what it's going to do is it's going to take a parameter that is a combination of a bunch of flags with bitwise operations. You will remember bitwise operations from one of the tutorials I've done. And it can be, let's say, parameter can be a bitwise combination of mix init fac and mix init mod, mix init mp3, and mix init OGG. And I believe it will always play WAV files by default, so if you pass in a WAV file, it should work. And these are just different file formats if you want to be able to support those different formats. So for instance, if we want to support mix, if we want to support MP3s, we can say mix init MP3. And if we want to also support OGG, we will do a bitwise OR operation with mix init OGG to pass that in. Now we should also be doing some error checking for sure. So let's go ahead and say if mix init, and this is going to return -1 if it fails. So if that returns -1, we're going to do some error checking. Let's go ahead and just use our errors. So we'll say include bingen errors errors.h, I believe. No, oh, I think since we're in bingen, we can just say errors.h. And actually, what I want to do here, one thing I want to do is, right now we have errors.h and errors.cpp. Let's actually rename those to bingen errors and bingen errors.cpp, because there's actually a Windows file called errors.h, and it's going to cause us some issues. That's something I didn't notice until recently. So I'm going to right-click, rename to, we'll say bingen errors.cpp and bingen errors.h. You can call it whatever the heck you want. So bingen errors.h, and this will be renamed to bingen errors.cpp. There we go. So now that's fixed. So we can include bingen errors.h, and we'll use our fatal error function. So we'll say fatal error, and it takes a string. We're going to say mix init failed, or we'll say mix init error colon, and I'm going to use string concatenation with the plus, and we're just going to say plus, and there's this function that the SDL Mixer has that will get the most recent error, and that's mix get error. However, mix get error returns a C string, so we need to convert this into a C++ string, and an easy way to do that is to just wrap it in an std string constructor here. And that will do that'll print out an error if we fail to initialize SDL Mixer for whatever reason. Now we need to do another function for initialization. It's funny that there isn't just one, and this is called mix open audio. And this will initialize some other things. It'll initialize the frequency for playing audio, it'll initialize the format, if you want stereo or mono, and the number of bytes to play at one time. And all of this you can just pretty much leave at the defaults and not worry about it. So we're going to go ahead and go with the default frequency, mix default frequency. And if you're in Visual Studio and you mouse over that, it'll tell you that's 22,050. I believe if you want to play MP3s, it's better to use twice that, so you can multiply that by 2 or something. But in general, this runs the best for most games to just go with the default frequency. It uses less processing power. For the format, we'll just use the default format, so we'll say mix default format. For the channels, the way this works is you say 1 if you want mono, and 2 if you want stereo, and we want to definitely do stereo audio, so we'll just say 2. And finally, the chunk size, I don't really know exactly what this has an effect on, but this basically says like how many bytes are in a chunk of audio that it wants to play at one time, or something like that. You can probably scour the documentation to learn exactly what effect this will have. I'm going to go with their default value of 1024. It does need to be a power of 2, so if you want to use bigger ones, you could say 20, 48, 40, 96, or 81, 92, something like that. I'm going to just go with the default. You can experiment with that and see if you notice anything, but I doubt you will. And of course, we want to error check that, so we're going to check if that is equal to -1. And if it is, we are going to do our same fatal error function here, like that. So that has initialized our audio engine, and what we should actually do is keep track of that. Let's remember when we have initialized it, and we'll say bool m is initialized equals false. So we'll set that to false by default, and we're going to come in here and set it to true after we're done initializing everything. And now in the destroy function, we can actually destroy everything, but only if we have actually initialized it, because we don't want to call all the destroy functions if we haven't initialized it. So that's why we have that flag. We're going to say if m is initialized is equal to false, no, is equal to true, or just if m is initialized, because that's a boolean, that's fine. Then we're going to go ahead and set it equal to false, since it's no longer initialized, and we're going to call mix quit, which will do a little bit of cleanup. Alright, so that's our initialization, that's our destroy function. Let's go ahead and also put destroy here in the destructor, just in case. just for extra precaution. If somebody deletes our audio engine, we still want to make sure we clean up the mixer stuff. And if you call destroy twice, nothing bad's going to happen because of this initialize bool. All right, so now load sound effect. This is the next part. So load sound effect is going to use a cache. So what we need to do is use an STD map, just like we did with the textures. So we're going to include map up here. And this is going to cache all of our different audio files. So let's go ahead and say std map, and we're going to use for the key, we're going to use the file path, which is a string. So we're going to say std string. And for the value, we're going to use, we'll do the effects first. We're going to use a mixed chunk pointer. So a mixed chunk, I haven't really explained it. This is basically a chunk, or this is basically just your audio file. It's like all the audio data that you can use to play. Since we only want to load a file one time, we only want to load the audio file once, there's no point in loading it multiple times, we should cache them here. Otherwise, we're going to end up loading a bunch of copies of the same file on accident, and it'll waste a bunch of memory. It's not very good. And we'll call this m effect map. And we also want one for our music, because there actually is a distinguishment between effects and music that SDL Mixer makes. With effects, you can play multiple effects at once, but with music, you can only play one music at a time. And we're going to say mix music star and m music map. There we go. So here are our little caches for all of our different effects and musics. So the first thing we're going to do is see if the music that that the user is asking for already exists. So we're going to use our handy little auto keyword, and we're going to say it for iterator equals m sound effect map, or effect map dot find. And remember, this will return an iterator, and we're going to look for file path. And auto will of course pick the correct type for us, so we don't have to type it out. So we'll say, all right, check, try to find the audio in the cache. And then now we can actually check and see if it did find it. Now remember, if iterator is equal to mEffectMap.end, that means it failed to find it. So we have to, we'll say, failed to find it must load. Else, it did find it, so it's already cached. Okay, so in here, we're going to need to create a new mix chunk. So we're going to say mix chunk star chunk, and we're going to load it. So the function we use to load a effect is mix load wave. Now I know it's called load wave, but I do believe, and I will test it in detail just to make sure. I may edit this video if it's not true, but I'm pretty sure you can load any audio file, including wave, that you've specified up here. So we can load MP3s and OGGs. We should be able to load those with this as well. Okay, so load wave, all it takes is the file path as a C string, like that, and that will load the file. So we should also check this for errors. So we're going to say if chunk is equal to null pointer, then that probably means we supplied an invalid file path. Check for errors. And in here we're going to do another fatal error. Let's just copy our, and this should actually be mix open audio error. Let's copy that, copy paste. I know it's terrible. And we'll say mix load wave error. And that'll print it out. It'll probably print something like file path was not found or something like that. All right, so if we get here, that means it successfully loaded it. So what we're going to need to do is cache the actual chunk in our effect map, since the next time we want to load it, or next time we call load on that file path, we want to get the chunk that we've already loaded. And we're going to treat the map as an associative array. I'm pretty sure I've taught you this. It's easier than calling insert. We'll just say mEffectMap file path equals chunk. And of course, this will create a node on the tree if it doesn't already exist and place that chunk there. And another thing we need to do is actually, since we're returning a sound effect here, we should probably create a sound effect. Sound effect, effect. This will be the effect we are returning. And here at the bottom, we will return that effect. And here we need to actually set the effect's chunk. So if you go up here to sound effect has this mchunk value here. Now we could write a setter function to actually set that. But if we write the setter function, that's going to expose our mchunk value to be modified by anything that has a sound effect. What we can do instead is we can use something clever called the friend keyword, which I don't think I've taught you. What we can do is say friend class, and we say what class we want to be a friend. And we're going to say Audio Engine is a friend. Now what this does is it says, okay, nobody can use my private variables, but Audio Engine is an exception. It can use my private variables. And the reason we want to do this is because the sound effect class and the music class are being managed by the Audio Engine. The Audio Engine is kind of authoritative on the matter, and it should be able to actually change these variables. So it's an exception. We're going to go ahead and make an exception and say the Audio Engine is special. He can touch the private variables. He can touch my privates. That's fine. So what we're going to do is, since we have made it a friend class, we can now successfully say effect.mChunk. See, we are accessing a private variable here equals chunk. Magic. All right, and now down here, this is for the case where it's already cached. All we got to do is say effect.mChunk equals it arrow second, like that. Because remember, iterator is pointing to a pair of, a pair of string and and mChunk pointers. So the second one is the mChunk, and we will set it here. Hope that made sense. All right, so that's it for loading a sound effect. Really simple. Now we're going to do the cardinal sin and copy paste this right here and change things. So instead of effect map, we should say music map here. Make sure you get all of these. You're going to have a nasty bug that's hard to find. That's what I like about Rock Margin, this extension I've downloaded, is it highlights all of the instances of the variable that I have currently selected, so I don't miss anything. Sound effect should be music, and we're going to say music here. So now I replace all instances of effect with music. And what else? So instead of .mChunk here, it's going to be .mMusic. Did we not do that? Class music, mMusic. Ah, right. So here's that issue. We can't set it because it's not a friend class. So let's make sure to make music, or let's make Audio Engine a fried class. No, a friend class of Audio Engine. There we go. Now we can set it, except we don't want to be using a mixed chunk here. So here's where things are a little different for music. Instead, we're going to be using a mix music. And we'll call this mix music, so it doesn't conflict with our music name up here. Now instead of mix load wave, we actually use a different function called mix load muse for music. And it takes a file path. And that will return the music. We do the same error check here, except instead of mix load wave, it's mix load muse. So we should change our error message appropriately. And we should copy mix music here. Yeah. What else? And mix music there. Oops, sorry, mMusic there. All right, so that's it for loading music and loading audio. So we're actually almost done with our audio engine. We need to implement a few more things. First, let's implement the sound effect play function. So I'm going to copy this and I'll put it up here. I'll put it above the audio engine stuff because that's how it is in the header file. And this doesn't belong to audio engine, it actually belongs to sound effect. And all sound effect play has to do is just play the sound. It's actually really, really simple. So what we do is we call mix play channel. And now this function has 3 parameters. The first parameter is what channel we want to play on. Now I think typically you have like only 8 audio channels, so if we try to play a bunch of audio, they're not going to all be able to play at once. FMOD Studio is actually really good for that. If you try to play a bunch of audio at the same time, it'll kind of pick the closest audio, and it does some intelligent stuff, but I don't think SDL Mixer is going to do that. But regardless, we'll just use -1 here. We're going to basically say, hey, pick the first channel that's open. Now we need to say what music chunk we're using, and that's just mChunk. And now loops. So this third parameter is how many times you want to loop the sound. If it's -1, it's going to loop forever. If it's 0, it's going to loop. It's only going to play 1 time. If it's 1, it's going to loop once, meaning it's going to play 2 times. You get the idea. So let's add a parameter to our play. We'll say int loops, and I'm going to set it to a default parameter of 0. Because by default, when you're playing a sound effect, you pretty much always just want to play it 1 time. So there's no reason to make them specify that. Int loops. Is that what I called it? Loops? Yes. And remember, you only specify the default parameter in the header file, but if you want to do something fancy, you can put a comment here so that you know that it has a default parameter. And we put loops here. Okay, and of course, we want to error check because we are good programmers. So if that equals -1, then we are going to do another fatal error, copy paste that, and this is mix play channel error. And that should be all we need there. So that will play the sound effect. And there's nothing in the constructor, so I'm going to specify that we know that. And we intended that by putting empty there. Okay, so that's it for sound effect play. See, it's very basic. Feel free to come in here and flesh this out. You can add functionality for pausing and stuff, and repeating and things like that, but that's a little more complicated because you have to keep track of what channel your audio is currently playing on. This mix play channel will actually return the channel that it's going to play on, one of those 8 channels or however many channels you have. So you could actually store the result of mix play channel and do things with it later, but we don't need to do that for our extremely basic audio engine. All right, now class music, we need to implement this as well. So let's copy that and put it below sound effect.play. All right, and this belongs to music. And what it's going to do is it's going to call a different function. It's very similar to mix play channel, but it's actually mix play music. And it's going to take the m music as the first parameter. And again, we have a loops variable. So for this, we'll just do, I guess, the same thing. We'll say int loops equals 0. And let's specify. So this plays the audio file. And I'm using Doxygen comment style here. And we're going to say param loops. That says that the parameter loops, if loops is equal to -1, loop forever. Otherwise... oh, actually, loops is different. Loops is different. I don't know why it's different, but it is. For music, 1 will play it 1 time, whereas 0 will play it 0 times, I'm pretty sure. Kind of weird. Otherwise, play it loops times. There you go. It's always helpful to have comments like these. And I'm going to copy this here. Plays the effect file, plays the music file. This is completely optional. I'm just doing a little documentation here. Loops equals -1, loop forever. Otherwise, play it loops +1 times. There you go. Kind of annoying. I'm pretty sure that's how it is. I'll go look at the documentation. I may be wrong, but I'm pretty sure. All right. So int loops, and this default parameter is equal to -1. Okay, that looks good. And we put loops here. There we go. So that will play the music. Now, music is special in that only one music can be playing at a time. So if you want to play a new music, it's going to overwrite the current music that is currently playing. So what we can do is we want to be able to stop and pause music, unlike sound effects. I mean, you may want to stop and pause sound effects, but it's much easier to do with music, and it's much more common to actually need it for music. And so what we could do is we could say void pause, and void stop, and void resume. These are 3 functions that are pretty useful. And since these functions are actually they don't apply to this music, they apply to whatever music is currently playing, that means they're kind of like global functions. They're going to apply to the single audio, or sorry, the single mix music that is currently playing, and you'll see why. So what we can do is make them static. We don't have to make them static, but we can make them static because the nature of what they do is static, since there's only going to be one thing playing. That was probably confusing. I'm going to copy all 3 of these into the CPP file, void pause. You don't need static in the CPP file. In fact, you can't put static in the CPP file. And we'll flesh this out, get rid of the semicolon, all that. Again, if you have Visual Assist, this is much faster. You can just press a button pretty much and it will do this for you. Music pause, music stop, and music resume. Alright, so these are really basic. Music pause is just a wraparound mix, pause music. And as you can see, we don't put any parameters in. This is pretty much like a globally function kind of thing. It's just going to pause whatever music is currently playing. That's why these are static functions. There's nothing in them that isn't static. For stop, we call mix halt music. And finally, for resume, we call mix resume music. Wouldn't you guess? All right. Resume music. And there's other functions like rewind music. There's other things this SDL Mixer can do, but you're going to have to go look at the documentation and see for yourself what it can do. And I'm sure there's other tutorials that may go more in depth, but all the tutorials I've seen so far don't create a handy little audio engine like this. All right, so I think that's it. I don't think we have any errors in here, and I think this is going to work just fine. So let's go ahead and use it. Now, in the description, you can download the sounds that I'm using. You can just go ahead and download the whole project, and the sounds will be included in it. And what I've done is I've added a folder called Sound to the zombie game. And inside I've got some sounds that I took from OpenGameArt. OpenGameArt also has music and sound effects. So the music file we're using is this xyz.ogg. OGG is a compressed audio format that is commonly used for games. It's a really good audio format. And this was made by Kistol. And we also have Michael Badari, who created this shots folder, which has all of these all of these different wave files for different guns. So like if we play shotgun.wave, that's, yeah, shotgun. That's cool. These are really good sound effects, actually. Pistol. Alright, so now we can add some sound to our guns, and this audio file here is a nice kind of creepy audio for, and it kind of fits our zombie theme, but of course you can use any audio you want, hopefully. There may be, I know some people were having issues with MP3s. There may be some issues with like the encoding for MP3s. One solution was to open it in the program Audacity and then save it again as an MP3, and that might fix it, but I don't know. There's probably going to be a lot of issues people are going to have with this. Alright, so let's use it. Let's go into main game, and let me make sure my mic is still recording. Yes, it is. Good. Alright, so anywhere we have binge and errors.h here, this is going to need to change to, I'm going to go ahead and do Control F. I'm going to find and replace everywhere. We're going to replace binge and errors.h with bingin and bingin errors.h, just so we're not conflicting with that errors.h file in Windows. Replace all. Yes. Alright, so that should get rid of that compiler error. Now we can actually use our audio engine, so let's go into main game and give ourselves an audio engine. So let's include bingin audio engine.h. Like that. No errors, thank you. And now we can go down and put one somewhere. I'll just put it here at the bottom with sprite font. So we're going to say bingin audio engine, and we'll say audio engine. Audio engine, because it's a private variable. Alright, so now we can initialize this. We'll go into init systems and initialize it there. So we can initialize it right after bingin init. Initialize sound must happen after bingin init. Alright, so audioengine.init. Easy as pie. Now we can load some sounds and use them. So what I'm going to do is I'm going to go ahead and right at the beginning, right before the game loop, I'm going to just start playing music, and I'm never going to stop the music. Feel free to do this better. But what I'm going to do is I'm going to call audio engine dot load music, and the music it's going to load is it's sound / xyz.ogg, like that. So that will load the music, and this returns a bingin music equals audio engine. Now you could save this music if you wanted to manipulate it later, but I'm only going to just play it once and then I don't care about it anymore, so it's fine if this stack variable goes away. We're going to call music.play. And now the default parameter says only play once, but I'm going to pass in -1 and have it loop forever. Alright, that will do our basic music. Now what we also want to do is do some sound for bullets. Now what you would probably want to do is assign a different sound to each of these different guns. So let's see, is that something we can do in a reasonable amount of time? I say yes. So what we should do is pass in a sound or a sound effect file to these guns on initialization. So let's go into gun.h and do that. Just going to add a little bit of extra time to our tutorial here, but I think that's okay. We're going to include engine slash audio engine.h. And we're going to store a Bingen sound effect, fire effect, like that. So now what we can do here is we'll pass in another variable, and since this is getting really long, I'm going to split it up into 2 lines like that. And we'll pass in a Bingen sound effect, fire effect, and of course this should be m underscore. We're going to get a name conflict here. We don't want that. And I'm going to copy this into gun.cpp right here. Gun.cpp, here we go. I believe that one was on the next line, and that is here. And, oh yes, so yeah, this is when you definitely need an initialization list. You can't header initialize these. We're going to say m fire effect, fire effect. All right. So now we have a sound effect that we can play whenever the gun fires. Why are we getting an error there? Expected identifier. I don't believe you. I bet it's lying to me. It was lying to me. So if we go to fire, anytime we call bullets dot in place back here, actually anytime we fire, we're not going to do it per bullet because that would make way too much noise. We're going to call m fire effect dot play. As simple as that. So I'm really hoping those wave files will work because I haven't actually tested the wave. I've only tested OGG. If it doesn't work, I'll do a little research and pause the video. But now let's go ahead and do some music files here for guns. So we're going to say, what is it, m audio engine dot load sound effect. And the sound effect we want to load for Magnum is, let's go to shots. We'll say sound slash pistol.wave, and it's actually lowercase. And let's see, we have pistol.wave, rifle.wave, and shotgun.wave. So we don't have anything for an MP5 machine gun, but I'm going to use rifle just to make it sound different. It'll probably sound stupid, but that's fine. Rifle.wave and shotgun gun.wave. And I think we're good. That should do it. Pistol, rifle, shotgun. What is this? Oh my god, rifle is not the correct one to use. We're going to use CG1 for MP5. CG1, that's probably some gun I don't know about. Okay. Let's test it. Alright, I'm going to go ahead and build and run. See how many errors we get. 113. Oh god. Alright, so unresolved external symbols and missing type specifiers. Errors.h stuff. This must have been an issue with me renaming errors. Give me just 1 second, you guys, to figure out what's going on here. So the issue with the errors file thing was we changed the errors include for zombie game, but we didn't change it for the actual game engine. It's still trying to include errors.h, which is valid in Windows, so that's why we're getting really bad bug here. So let's do Control F, and I'm going to change include errors.h. I'm going to change that to the correct one, which is include Bingen errors.h. That should get rid of most of our hundreds of bugs here. Alright, now let's compile again. I think we may still have those library errors, but actually we won't because the issue was that our engine was not compiling. Alright, let's see if we get sound. Ah! Mix load wave RW with null source. So the sound effect files are failing to open for some reason. Or they're failing to play. Mix load wave with null source. Let's take a look. Alright, so the bug was caused just by my stupidity. The sound files are actually inside the shots subfolder, of course, so we should say shots there. And that will, in theory, fix our bug. And there we go. Do I have any debug code left in there? I don't think so. Alright, so let's try again. And there we go. Alright, if you listen closely, you can hear... Oh wow, I'm getting 2 FPS because I'm in debug mode. Hold on, let's go to release. Debug mode cannot handle 1,000 humans. Not at all. Optimization is key. There, now we're getting a good 20. Yeah! Alright, let's use some better guns. Yeah! Alright, so the machine gun worked for a little bit. However, if there is no free channels available, then what happens is it just stops playing the sound. So we need to overcome that. We actually get an error if it stops working. So let's change that. That's one thing I was worried about that I didn't actually test for. My bad. If we go to Audio Engine, Music, or Sound Effect Play, here we go. Instead of calling just a fatal error here, where we get this play channel error, what we're going to do is we're just going to call play channel again just on the first one. So we're going to say we're going to manually use channel 0. So we're just going to overwrite whatever song is in, or whatever audio is in channel 0. Now this is probably going to cause us some, it's not going to be very pretty, but we'll see. Alright, so let's see what happens. Now if this fails again, then we have an issue. So if both of these fail, something is really going wrong. But if only the first one fails, that probably just means that we are out of channels. Alright, so let's go ahead and run that. Now let's see what happens if I use the machine gun. There we go. So if the machine gun wasn't shooting so fast, it might be able to keep up better. But for now, this works. It's probably really loud for y'all. I'm not sure how loud it is. I'm sorry if it's super loud. Alright, so that is the audio tutorial. Now you have basic audio for your game. And you can use this. We're pretty close to having everything you need for all your basic games. One thing we haven't learned is animation. We should definitely do some 2D animation stuff with sprite sheets and all that. And spatial hashing, still want to do that. We'll probably do spatial hashing first so we can optimize this game even further. Thanks for watching, guys. I hope this helped. If you have any issues, please let me know. And just so you know, there's probably a better solution for this right here. I'm always using the first channel, but it might be better to loop through all available channels and just use a counter and just use random channels or something like that. So we're not always using the first one. If we always use the first one, it kind of causes our audio to choke a little bit. It seems like we should, in reality, what we should be doing is using the channel that is the oldest channel that is currently still in use. But you'll probably want to look through the documentation for how to do that because this video has come to a close. All right, thanks, guys.